Alright, so this is going to be another video about limit properties, and it's called the rationalizing technique. And basically it involves using conjugates to rationalize a number. Okay, so an example right here is I have the square root of x plus some constant c. Now the conjugate of this would be the exact same expression as this right here, only instead of a plus, whatever that middle operation is, in this case it's a plus right here, we would just do the opposite of it, so it would be a minus. So if I took this entire expression right here and I multiplied it by the square root of x, this time only minus c, you'd end up having to distribute this out. You'd have the square root of x times the square root of x, which is equal to x. So now we no longer have the radical sign. So I multiply these first two radicals together to get this x. Then I'm going to multiply this first radical by this minus c, and you'll get negative c root x. Okay, then we're going to do this c, and we're going to distribute this to the square root of x over here, and you'll have plus c times the square root of x. And then we're going to distribute the c right here, so we have positive c and negative c, so it'd be minus c squared. Okay, these middle terms right here, there's a minus square root of x plus c square root of x. This would cancel out right here, and you'd be left with x minus c squared. So if you notice now, this is rational. Okay, it's not a radical number anymore. It doesn't have any square roots or anything. Okay, we're going to use this in the rationalizing technique to solve other problems. For example, this one right here. Okay, first thing I'm going to try, because I'm going to always try this, is to use direct substitution. So I'm going to put the 0 into the numerator, and you'll end up getting 0 plus 1. The square root of 0 plus 1 is 1. Okay, the square root of 1 is 1. Minus 1 is 0. So we have 0 on the numerator. Okay, and then if I plug in 0 in the denominator, I also have 0. And then so we have that indeterminate form again. We have a 0 over 0. Okay, when you have a 0 over 0 and you see this square root sign, it's a good indication that you might be able to use this rationalizing technique to solve this. So that's what we're going to do to solve this. We're going to use the rationalizing technique. So what we're going to do is we need to get rid of this radical right here. Okay, so we have a square root right here. In order to get rid of that, we're going to use this conjugate like we did over here. So I'm going to multiply this numerator by the square root of x plus 1, only this time instead of minus 1 after it, I'm going to do plus 1. So now this is a conjugate with this over here, with this numerator. Okay, now what you multiply the top by, you also have to multiply the bottom by. So then technically we're just multiplying this function right here by 1. So times x plus 1, square root of x plus 1 plus 1. Okay, now if you multiply this numerator out, you will get the limit as x goes to 0 of x plus 1 minus 1 over x, and then I'm not even going to distribute, I'm just going to keep this factored here. So we have the square root of x plus 1 plus 1. Okay, let's cancel some things out if we can. So we have this 1 minus 1 right here, so that'll cancel out. So now you just have x on top. Okay, x divided by x, since we have an x right here and an x right here, x over x is 1, so I'm going to cancel this out. So you'll end up having 1 over 1. So now I'm going to rewrite this, and it'll look like x, or limit as x goes to 0 of 1 divided by square root of x plus 1 plus 1. Okay, now you'll be able to do direct substitution because I can just plug the 0 in right here. So you'll end up with 1 over the square root of 0 plus 1, which is just 1, plus 1, which is equal to 1 over 1 plus 1, which is equal to 1 over 2. And then we end up having a limit, and we solve the entire thing algebraically. Even though in the beginning we couldn't do direct substitution, using this rationalizing technique, we were able to come up with a limit. So if you have any questions about the rationalizing technique, let me know.